we have to support pipelining. What is pipelining? Pipelining is nothing but sending so multiple chunk of data before receiving the ARQ instead of just sending one. That is what is called pipelining. At the same point of time, we can send more data instead of go and sending only one data, but with a constraint, not infinitely. I cannot go and send continuously to the other end, so infinitely, rather with a constraint. So that means we have to support pipelining with a constraint. With a constraint. What is that constraint? That constraint is, so we have to define a send window size. What the send window size is telling? Send window size will tell me what is the maximum number of packets I can go and send before receiving the ARQ. Okay, so here I have to support pipelining, I have to support sending of multiple packets, but with a constraint. I cannot go and do it infinitely. So what is that constraint? So that depends on the send window size. And what the send window size implies? Send window size implies that if I say my send window size is n, so that means I can go and send n number of packets maximum. So before receiving that, let's say I have already sent n number of packets, I did not receive that, so I cannot send so the n plus 1 packet. Okay, I have to send maximum n number of packets before receiving the ARQ. So thereby improving the efficiency, and also the server at the receiving end is not going to overwhelm. So this is how I'm going to provide a solution on top of this stop and wait ARQ, so to support this. And as far as the supporting pipelining is concerned, so there are two protocols available to support this pipelining. One, the first protocol is go back N, and the second one is selective repeat. There are two protocols who supports pipelining to improve the efficiency of channel utilization. And first protocol is go back N. So let's look into the go back N a bit for today class. Okay, as a part of today. So let's go for go back N. Go back N. Go back N. Okay. So what the go back N protocol is saying? So first of all, I could able to send multiple packets. As I have already told, I can go and send so multiple packets before receiving the ARQ. Let's say this is I send a packet with sequence number 0. The next packet is a sequence number 1. The next packet is a sequence number 2. The next packet is a sequence number 3. So I send 4 packets. Okay. So based on my capability, my window size is, let's say my send window size is 4. Let's say for example. So I can go and send 4 packets. After that, I cannot send any packet. Okay, I can send 4 packets before receiving that. Now, let's say all these 4 packets are received successfully. Can anybody tell me what should be the value of ARQ I should provide here?
4.
4. So it should be 4. If the sender is receiving a ARQ of 4, usko kya knowledge aa gaya? So usko knowledge mein aa gaya. So now, so the receiver has received packet so from 0 to 3 successfully. That's why he is expecting a next packet with a sequence number of 4. That's why the ARQ is 4. Okay, that is the first understanding. Next, let's say you send 4 packets. Now let's say you send 4 packets, like packet with sequence number 0, packet with sequence number 1, packet with sequence number 2, packet with sequence number 3. Okay, and now it has to, as a result, it has to generate an ARQ. Okay, so can anybody tell me what should be the ARQ here?
2.
Very nice. So it should be 2, because so this is a cumulative ARQ. So go back and protocol supports cumulative ARQ. So cumulative ARQ says if it is 2 means 0 and 1 receive successfully. Even 3 is received successfully. It is a out of order packet. That means, so if at all I have to receive the packet in order, not out of order. So as 2 is not received, after that 3 is received, so that is called as a out of order packet, and the receiver is going to discard the out of order packet as far as go back N protocol is concerned. So even if it is received the packet, so that's why, so whenever it is going to receive 2, so what it is going to do? It is going to retransmit the packet with sequence number 2 and 3 once again. Okay, so to deal with the scenario, so that's why try to understood what I'm saying. So go back N protocol supports cumulative back, and it can send packets based on the window size. Send window size. Let's try to understood. So how window size is going to be decided. Okay, so window size decided based on the, so what is the sequence number? Sequence number is, so if I say there are m bits to represent the sequence number, like in case of stop and wait ARQ, I have only 2 sequence number, 0 or 1, 0 or 1. So in order to represent 0 or 1, how many bits I need? 1, na? So 1 bit is required to represent the sequence number as far as stop and wait ARQ is concerned. But as far as go back N protocol is concerned, with 1 bit, I cannot represent my sequence number because I have to send multiple packets. So that's why let's assume there are m bits required to represent my sequence number. That means I can have the range of sequence number 0 to the power m minus 1. Okay, so based on this, if I go and find what is the window size, let's try to understood window size as far as go back N protocol is concerned. So there are basically 2 windows we have to deal with. We have already talked about. So previously, sender has to adjust its capability based on the receiver. So there are two windows. One is a receiver window, one is a sender window. So as far as window is concerned, one is called as a send window, other one is called as a receive window. Okay, so what is the send window size as far as so go back N protocol is concerned? So that is 2 to the power m minus 1, provided m is the number of bits to represent the sequence number. If so, my go back N protocol is using m bits as a sequence number to represent. So what can be my maximum send window size? It should be 2 to the power m. So this window size will be decided based on the number of bits is used to represent the sequence number. That's why I told that my sequence number is 2 to the power m minus 1, means my window size is also 2 to the power m minus 1. But what about receiver window? Receiver window is 1. Okay, receiver window is 1, receiver window size is 1 as far as go back N protocol is concerned, whereas the send window size is 2 to the power m minus 1 as far as the go back N protocol is concerned. So based on this, so we'll talk about using this. If it is 2 to the power m minus 1, obviously how many packets I can go and send before receiving that? 2 to the power m minus 1. How many packets I can go and send? So before receiving the ARQ, so maximum to maximum I can go and send, so 2 to the power m minus 1 packets before receiving the ARQ. Okay, so that is the first concept you have to understand. But now somebody can ask, sir, why 2 to the power m minus 1? Why it is not 2 to the power m? Or why it is not something else? Why it is not 2 to the power m plus 1? Why you are saying it is 2 to the power m minus 1? What is the concept behind the cell? So you have to understood that concept. In the next class, we'll talk about one scenario. If so, the value of send window is somehow greater than 2 to the power m minus 1, what kind of problem is going to arise? So we are going to face problem if the window size is going to greater than 2 to the power m minus 1. So what are the problem we are going to face? We are going to discuss in the next class. So that's why there is a constraint on the send window size. Is maximum send window size in a go back N protocol is 2 to the power m minus 1, where m is the number of bits in ARQ. In the last class, we only discussed about what is the send window size. Send window size is equals to 2 to the power m minus 1, provided m is the number of bits representing sequence number. Number of bits representing the sequence number. Okay, and the receive window size is equals to 1. That's what we just discussed in the last class. Okay, now before going to talk about, because somebody has asked me a question, sir, 2 to the power m minus 1 क्यों है? Okay, if it is, so that means what I saw, this is the maximum window size. That means a window size can be either less than or equals to this 2 to the power m minus 1. Okay, it should be always, the window size always should be 2 to the power, less than, either less than or equals to 2 to the power m minus 1. But it can never be greater than, 2 to the power m minus 1. This should not happen. If this is going to happen, what is the problem? Let's go and discuss today. But before going to discuss about the problem associated with, so the window size more than 2 to the power m minus 1, let me talk about, so how the send window and receive window actually, what is the significance of, so send window and receive window in more detail. Let's talk about send window first. If I say m is equal to 3, can anybody tell me, so what is 7, 2 to the power m minus 1? And what is the range of sequence number? What is the range of sequence number I can have? Means 7 means, so my range of sequence number is 0 to 7. Na? Highest number I can represent with a, so 3 bit is 7. Lowest number I can represent with a 3 bit is 0. So my range of sequence number is from 0 to 7, whereas the send window size is 7 if m is equal to 3. This is the first thing I have to understand very clearly. Now, based on this concept, let me go for, so understanding what is the significance of the send window. Okay, let's talk about this. Let me just go and write 7 means 0, 1, 2, 3, 4, 5, 6, 7. After 7, what is the sequence number? Again, it is going to be repeated, na? 0, 1, 2, 3, 4, 6, 7, 7. 7 is the highest number I can store. So obviously it is going to repeat, na? So that's why next sequence number again going to come as 0, 1, 2, 3, dot, 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 dot. Okay. Similarly, prior to this, there must be a sequence number 7. Prior to this, there must be a sequence number 6. Prior to that, there must be a sequence number 5, dot, 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 like this. Okay. Now, so let's say now my send window size is 7. Let's say my window is at this position. This is my current window. 7 means it has started from 6, go up to 6. It has started from 0 and go up to 6. This is my current window. This is my current send window. This is an example I'm giving. Let's say currently, so when I say send window, a send window has a left wall. This is called as the left wall of the send window. This is, everybody please listen very carefully this concept. So this is called the right wall of the send window. One window is having a left wall and right wall. Okay. As I'm saying, my assumption is here, my left wall is on, so packet number 0. Okay. Or so packet having sequence number 0. And my right wall is going to be on sequence packet with sequence number 6, because my send window is 7. So that means I can send maximum 7 packets before receiving that. And what are the sequence number that I can send right now? Starting with 0 and ending with 6. So these are the valid sequence number I can go and send. So as far as this send window example is concerned. So let's try to understood. So what is the left? Whatever present to the left of the left wall, what is the meaning of it? These packet with this sequence number are already sent and already acknowledged. They are already sent and acknowledged. Sent and acknowledged. Try to understand this. Acknowledged. That means I have already sent packet with sequence number 5, 6, 7, and the other end has already sent an ACK on behalf of it. So that's why they are present to the left wall of it. Left wall of my send window. And whatever is present to the right wall, what is the significance of it? I cannot send any packet with this sequence number at this moment. With this sequence number at this moment. That means whatever sequence number present to the right of me, okay, right of my send window, I cannot send a packet with that sequence number. And whatever is present to the left wall of, left to the left wall of it, so those are the packets that have already been sent and already I receive an acknowledgement on behalf of it. And what is there within the window? What is the significance of it? Now I can send a packet with this sequence number. Now I can send packet with these sequence numbers. These are the valid sequence number I can send a packet with. This is the significance of this window first. Okay, now, so based on this, let's try to understand one more concept, another important concept. There are two pointers will be available here. Okay, so one pointer pointing so to one packet, let's say it is called as a SF. One pointer is called SF, another pointer is called as SN. Let's say this is another pointer that is called SN. Okay, what is this SF and what is this SN? Try to understand. So SF is SF pointer points to the first outstanding packet. First outstanding packet. It is going to point to the first packet which is first outstanding. Okay, I will tell what is exactly does it mean. So SN means next packet that can be sent, that can be sent at this moment. What does it mean? That means what if my SF is pointing to 0, my SN is pointing to 4. What is the meaning of it? That means packet 0 is sent already, packet 1 is already sent, packet 2 is already sent, packet 3 is already sent. Now if I want to send a packet, I can go and send a packet next with a sequence number of SN. Okay, that is sequence number of 4. So is SN, so to whomever sequence number SN is pointing to, now at this moment I can go and send a packet with that sequence number only, because so all the previous sequence number I have already sent. Okay, that means why it is the first outstanding? So because see 0, 1, 2, 3, so these are the 4 packets. 0 packet, packet with 0 sequence number, packet with the 1 sequence number, packet with 2 sequence number, and packet with 3 sequence number. All these packets are already sent. Okay, but I did not receive a ARQ on behalf of them. I have already sent a packet, but I did not receive a ARQ on behalf of them. So out of them, so that means all these 4 packets are outstanding packets. That means what are the outstanding packets? So outstanding packets are those packets for whom I have already sent the packet, but I did not receive an ARQ on behalf of it. Okay, and out of them, out of these 4, which one is the first outstanding? 0 is the first outstanding. So that's why, so SF pointer is pointing to the first outstanding packet. First outstanding packet is nothing but, so that is the first packet I have sent till now, and I did not receive an ARQ on behalf of it. So that's why that is called as the first outstanding packet. And the pointer SF is always point to the first outstanding packet, first outstanding packet in a send window, whereas SN pointer is going to point to the next packet that can be sent at this particular moment. So as far as the send window is concerned, okay, that is the first significance of what is the send window. So as far as our M is the number of bits that is representing the sequence number, in this case it is 3. So my send window becomes 7. If the send window becomes 7, as far as M is equal to 3, so range of sequence number is from 0 to 6. And currently now left wall of the window is at the packet number 0, and right wall of the window is packet at with the packet number 6, because my window size is 7. And so now SF points to the first outstanding packet. That means the packet first I have already sent, but I did not receive an ARQ on behalf of it. And SN points to the packet which I can go and send at this moment. So if I want to send a packet, that is what is the significance of this window. Based on this, now let me go for the next part of it. That is, let's say at this point of time, what happens? So scenario wise, I am going to discuss. Let's say first what I do at this point of time, I receive an ARQ. I receive of, let's say 2. Let's try to understood. Now this is my current window scenario. SF is pointing to 0, SN is pointing to 4 at the receiver end. Are you getting my point? Yes or no? So whenever I am receiving an ARQ of 2 from the receiver, so that means it is acknowledging that I receive 0 and 1 successfully. That's why I am sending 2, means I am expecting in the next packet with the sequence number of 2. Getting my point, everybody? So if that is the case, now look into how my window is going to change. That is very, very important to understand. How my window is going to change, everybody. So look into carefully. Okay. So this is my 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4. So previously मेरा window कहाँ था? So now the left wall of the window is at 0, right wall of the window is at the 6. But now when I say I receive an arc of 2. So that means 0 and 1 packet are successfully received at the other end. Where should my SF? So my SF should point to this. Is everybody agrees? Previously my SF was pointing to 0. So now arc 2 conveys me that 0 and 1 successfully received. That means, so they have sent and acknowledged. So what is my first outstanding packet then? So that becomes 2. And I have already sent 3. Okay, so that's why if my first outstanding packet is 2, remember, always the left wall of the window remains with the first outstanding packet. So previously my left wall of the window was 0, but right now as the first outstanding packet is 2, so my left wall of the window will slide from 0 to 2. That means previously it was here. It was here. Now it will slide by 2 position and it will move to 2. So that's why this is called as a sliding of window. This is called as sliding of window. So that's why, so this protocol, go back N protocol, is also called as a sliding window protocol. Okay, so this protocol is called as a sliding window protocol. So depending on the send and receive, so the window is going to slide from time to time depending on what is being sent and what is being received. So during the data transmission. So that's why now what happens? The left wall of the window is so moving to the 2. If left wall of the window moves to 2, so then in order to make a window size of 10, my right wall of the window will present where? Can anybody tell me? Right wall of the window is at 0. So that's why this becomes my new window. This becomes my new window. Try to understood. Okay. Now new window becomes, so left wall of the window remains at 2 and right wall of the window remains at 0 to make it 7, because window size is 7 na? To make it 7, so my right wall, if the left wall moves by 2 position, then the right wall has to also shift by 2 position. Previously the right wall was at 6. So now if it is going to, previously the right wall is here. If it is going to move by 2, so now it is going to present at 0. So that's why the new window becomes, so where the left wall of the window is remaining at 2 and the right wall of the window remaining at 0. And my SF pointer points to 2. Now at this moment, let's say I go and send 2 more packets. I go and send 2 more packets. 2 more packets may be 6 now. If I go and send at this moment, so 2 more packets after receiving the arc, so 2 from the other end. So that means now my SN pointer is moving to 6, my SF pointer is moving to 2, and the current window is this. And so this is called as a sliding of the window depending on so what you are receiving and sending so to the other end. So this is what the first concept you have to understood as a part of send window. Okay, so next another scenario. So let me go for another scenario. Okay, so now this is the current scenario. So let's go for another scenario. What is the next scenario? Let's say, so now at this point of time, the receiver, the sender receive an arc of, let's say 5. Okay, so if the sender is going to receive an arc of 5 successfully, so then just let me write this so that you tell me 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5. Now, so 2, 3, 4 received successfully. If I receive an arc of 5, it is the meaning that so 2 and 3 and 4 are received successfully. If that is the case, so my SF pointer will point to whom now? To whom my SF pointer is going to point? An arc of 5 is saying that I'm expecting a packet with a sequence number of 5 next. So that means there is no guarantee whether 5 has received or not till now. So that's why, so it is 2, 3, 4 has received. If 2, 3, 4 has received, what is the first outstanding packet right now? 5. So 5 is the first outstanding packet. If the 5 is the first outstanding packet to whom SF is pointing to, so my left wall of the window will be present here. This is my left wall of the window. Yes or no? This is my left wall of the window. And if the left wall of the window remains at 5, where should be 4, 5, 6, 7 at 3? I have to make it 7 because the window size is 7. In order to make the window size is 7, so right wall of the window should be present at 3, so that now my window size becomes 7. Okay, and so this is the first outstanding packet, so which is being sent but till now not acknowledged. Now at this point of time, I let's say go and send one more packet. I go and send one more packet. If I go and send one, so my SN pointer moving forward, and that becomes 7. That means after receiving an arc of 5 and sending one more packet, my SN pointer points to 7. Okay, so this is what the significance of what is a send window. In send window, we should understood there is a left wall, so there is a right wall, and there is a SF pointer, there is a SN pointer. SF pointer is the first outstanding packet pointing to, and SN pointer is the packet that I can go and send at this moment. Next, if I want to send a packet. Okay, so based on this, all the send and receive, so communication is going to happen between the send and receiver by using the concept of this window. And this window is going to change from time to time, or going to slide from time to time, depending on what we send and what we receive, so from the other end. Okay, everybody got it? What is the significance of send window? Now let's talk about receive window. Receive window is pretty simple. Okay, let me go for that still. So let's go for the receive window. If I look into the receive window is pretty simple as compared to send window. If this is my, let's say 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, da, da, da. Okay, now whenever I say receive window, what is the size of the receive window in go back and 1? Okay, that means let's say for the time being, my receive window is at this point. Just for an example, my receive window is pointing to this. So that means whatever pointer is being using or being used to point to a receive window, that is called RN. Okay, so if RN pointer is pointing to this and the receive window size is of 1, what is the meaning of it? The meaning is that the receiver is now expecting a packet with a sequence number of 3. That means what RN pointer is pointing to, so to whomever sequence number the RN pointer is pointing to, the significance of that is that so the receiver at this moment is expecting a packet with that sequence number. Okay, so that's why, so always RN pointer is pointing to that sequence number what the receiver is expecting at this moment from the center. That's pretty simple. And what is the meaning of it? Now, whatever is present to the left of this window, what is the meaning of it? These are the packets I have already received. And so what is the significance of the sequence number that is present to the right of it? So if I receive a packet so with a sequence number with this, so this becomes invalid packet for me. If at all the receiver is receiving, so let's say at this moment RN pointer is pointing to 3. At this point, let's say the receiver is receiving a packet with a sequence number of 4. So that means that is an invalid packet for me. Okay, I cannot handle that packet. I should go and reject that packet. Okay, so that becomes an invalid packet for me. So that's, I should go and discard that packet if I go and receive an invalid packet. But if I receive a packet with a sequence number 3, that is only valid for me. I should accept that packet, and then accordingly I should go and once, let's say at this point of time, try to understood. Let's say at this point of time, the receiver receives a packet with a sequence number of 3. So now RN is pointing to 3. It is expecting a packet with sequence number 3. It also receives a packet with sequence number 3. At this moment, what is going to happen? Now the RN pointer is going to move. So now it is 0, 1, 2, 3, 4, 5, 6, 7, 0, dot, dot, dot. Okay. Now what is going to happen? So previously RN was in 3. After receiving this packet with the sequence number 3, what the RN is going to do? RN is going to move to 4. That means now my new window is pointing to so this 4. That means now I am expecting a packet with the sequence number 4 from the other end. So that means this is how my receiver window is going to move. So depending on what I receive. But at this moment, let's say it is expecting 4. So now at this moment, it receives some packet with a sequence number of 5. Okay. So now in this scenario, if it is receiving a packet with sequence number 5 at this point of time, as RN is pointing to 4, but I am receiving a packet with a sequence number 5, that is an invalid packet for me. Sorry. That is a invalid packet for me. If it is an invalid packet for me, so there is no change in the window. So there is no change in the window. That means, so now the Rn pointer is still going to point to the same sequence number 4. It is not going to change. So as the packet I have received is an invalid packet, and if it is an invalid packet, I should go and discard the packet. The receiver should go and discard it. Everybody got it? It receives the packet 3 first. Okay. If it is receiving the 3 first, so then 4 next, 5 next. So it will process 3 and it will keep 4 and 5 in the buffer. Then Rn pointer is going to move to 4. Then it is going to process the 4th packet to sequence number 4. So then, so Rn pointer is going to move to 5. So then it is going to take the packet with sequence number 5 from the buffer and it is going to process. Okay. So one by one it is going to process now. So that's why, so 3, 4, 5. But let's say, so 3, 4, 5 has been sent, but 3 is received, 5 is received, 4 is lost. In that case, even if 5 is a so correct packet, it is going to discard. We're going to talk about that. Don't worry. Okay, is send window size should be either less than or equals to 2 to the power m minus 1. This is what we are this is what we have talked about. Now the question is, if it is greater than 2 to the power m minus 1, what is the problem? Let's try to understand. Okay. So now let's say I assume that my window size is greater than 2 to the power m minus 1. And see what the problem I am facing. So let's say my m value is equal to 2. If my m value is 2, what should be my window size? 2 to the power m minus 1 means 2 to the power 2, 4 minus 1, 3. My window size is 3. मेरा window size ज़्यादा से ज़्यादा 3 होना चाहिए as per the rule. But let's say I assume my window size is 4. I go beyond it. I assume that, let's say, take the window size as 4 and see what problem we are going to face as far as this window size is concerned. Let's go and understood that concept in clear. This is my sender, let's say. This is my receiver. Now, if it is a send window size of 4, if I look into here, so what are the sequence number possible? What are the sequence number possible?
0 to 4.
0, 1, 2, 3. Huh?
Yes, 0 to 3.
0, 1, 2, 3. Then it is going to repeat it 0, 1, 2, dot, dot, dot. Okay. Now, when the sender is going to send the first packet, so he can go and send the packet with the sequence number 0. Now, sender sends the packet with the sequence number 0. Sender sends the packet with sequence number 0. Can anybody tell me after sending the and window size kitna bol rahe hain? Window size is this much. My window is 4. 4 means now my window is this much. This is my window, current window. Okay. Now, when I send the packet with sequence number 0, can anybody tell me after sending this packet with sequence number 0, where is my SF and where is my SN? Tell me now.
SF 0.
SF is 0. So that means 0 packet I have already sent. So my SF pointer points to Rn pointer is pointing to 0. Initially at the beginning, the receiver is expecting a packet with sequence number 0. So that's why Rn is pointing to 0. So now Rn is pointing to 0. I send a packet with sequence number 0. It is received successfully. Can anybody tell me what is going to happen to the Rn? What is going to happen to the Rn? Is it a valid?
Rn
At the receiving end, it is a valid packet or invalid packet? Rn is going to move. Rn is going to move to 1. After receiving this, Rn is going to move to 1. That means expecting a packet now with a sequence number of 1. So thereby generating an arc of 1. Thereby generating an arc of 1. Now let's say this arc is lost. If this arc is lost, can the sender send the, what is my window size in the go back end is 4. What is the meaning of it? Before receiving an arc, I can't send 4 packets. So ये arc loss हो गया, मैं example दे रहा हूँ, but so sender do not know. So whether the arc is lost, it is still in the transit coming to me. So it is not going to wait for the arc to receive. So rather it is going to send 4 packet point. Even if the arc is lost, let's say for example, still the sender can go and send the next packet. If anybody did not, please ask. So if it is going to send the next packet, what should be the sequence number of the packet? My situation is 0, 1, 2, 3, 0, sorry, 1, 2, dot, 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 So this is my window. Okay, now 0 is already sent, 1 is, yes, very nice. So SF is pointing to 0, SN is pointing to 2, correct. So now I send a packet with sequence number 1. So whenever it is so received, is it a valid packet or invalid packet? Now it is going to, what is going to happen? RN is going to move. RN is going to move. So now RN is moving to 2. After receiving this packet, RN moves to 2. If RN moves to 2, that means now it is expecting a packet with sequence number 2. Now, so it will generate an arc of 2. That is lost. Arc of 2 is generated, that is also lost. So if arc of 2 is generated and that is lost, so still I can go and send the next packet. So that's why now my sender is going to send the next packet with a sequence number of 2 because SN is pointing to 2. Okay, so then when it is receiving here, so it is expecting to receiving 2 valid packet. So RN is going to move forward. So 1, 2, 3, 0, 1, dot, dot, dot. So RN moves forward. Okay, so thereby generating an arc of 3. So at this moment when it is sending arc of 3, so still, so that means expecting a packet 3. So 3 is in within my window. That means 3 is still a valid packet for me to send. So that means now I can go and send the next packet with a sequence number of 3. Okay, so when it is receiving, it is expecting 3, receiving 3, valid. So now, so look into very interesting here. 0, 1, dot, dot, dot. So now my RN pointer moves. Now my RN pointer pointing to 0. As a consequence of it, it is going to so send an arc of. I am assuming everything is lost. Every arc is lost. So no arc I have received till now. So that's why. So my SF pointer at this moment, my SF pointer is pointing to 0. My SN pointer is pointing to 3. Okay, that means so SN pointer 3 means 3. It is not exactly 3 actually. So 3 is already sent. Okay, so you can say SN pointer is pointing to 0, but I cannot send that packet because that is a invalid packet for me. Okay, as this, so this pointer is falling outside of my window, that is an invalid packet for me. I cannot go and send any packet at this moment. So that's why. So now this is a scenario when I have already sent 4 packets, but still I am waiting for an ARC to receive. अभी क्या होगा? इसके बाद क्या होगा? मैं भेज नहीं पाऊंगा पैकेट. I start a send a packet. I have already told you in the last class. I start a timer. Okay, every time I send a packet, a timer is being started. So let's say, so when packet 0 is being sent and the timer has started, I did not receive any ARC within the timeout period. So what is going to happen? Retransmission of the packet is going to happen. And who are the packet going to be retransmitted? So those who have not acknowledged, those packets already have sent, but not acknowledged. So those packets all are going to be retransmitted. So that's why, so all the 4 packets are going to be retransmitted. In this case, so the first packet that is going to be retransmitted is packet with sequence number 0. That means whatever is the first outstanding packet that is going to be retransmitted here. That means in this case, what is going to happen? SN will come back to here. Okay, SN is, whenever the window is full, you did not receive an ARC, at that point of time, SN comes back to the SF pointer so that it can go and retransmit those data. That means SN is pointing to 0. After sending the packet 0, SN moves to 1. Okay, so then if I go pointer is expecting a packet of sequence number 0, it is receiving a packet of sequence number 0. How do you know it is a duplicate packet? अरे मैं एक्सपेक्ट कर रहा हूं पैकेट इज सीक्वेंस नंबर 0, मुझे मिल रहा है पैकेट इज सीक्वेंस नंबर 0. So that's why I will not treat it as a duplicate packet, rather I will treat it as an original packet. Try to understood. So receiver at this point of time is going to treat this packet not as a duplicate packet. So rather it is an original packet because it is expecting now a packet with a sequence number 0 and it is receiving a packet with a sequence number 0. That's the correct packet for me. So it is not an invalid or not a duplicate packet for me. So that's why. So if it is going to happen, is understanding as far as the so sequence number is concerned at its own end. So his understanding it is a valid packet for me. So this is completely wrong scenario, wrong understanding at the receiver end. And why it happens? Because of this how restriction is concerned, I go by the restriction, I make it the window size 3. I go by make window size 3. That is what is the rule. As per the rule, in this case, window size maximum can be 3, na? but I have violated it and go up to 4. That's why this problem has arisen. Let's go with window size 3 and see whether that problem is arising or not. This is my sender. This is my receiver. Okay, so this is 0, 1, 2, 3, 0, 1, dot, dot, dot. Here my window size is 3. 3 means 0 to 2. Okay, here my window is 0, 1, 2, 3, sorry, not 4, 0, 1, dot, dot, dot. Okay, and my RN is pointing to 0. Now, so I go and send the first packet. Packet is sequence number 0. Okay, so then RN is pointing to here. So sending an arc of 1. Then RN pointer moves. RN pointer moves now. 0, 1, 2, 3, dot, dot, dot. RN pointer moves. Okay, so now arc of 1 is lost. Then I go and send a next packet. Packet is sequence number 1. Okay, so 0 is sent. I'm just marking it. 0 is sent. So then I go and send. So this is the first outstanding packet now. SF is pointing to this. Okay, SF is pointing to 1. So now I send a packet 1. Okay, that means now I have already sent a packet of 1. Okay, so then RN pointer moves. 0, 1, 2, 3, 0, dot, dot, dot. So now it is moving to 2, thereby generating an arc of 2. Arc of 2. Okay, so if it is arc of 2, other end is supposed to send on packet with sequence number 2. Now packet with sequence number 2 is sent. Okay, now the arc of 3 is going to be generated. So because RN pointer is going to move to 3 after receiving this arc. Okay, sorry, packet. So now what is going to happen after sending this arc? This is also lost. Now after this, as my window is already full, I have already sent 0, 1, 2, and my window size is 3. Can I send any more packet? Yes or no?
No, sir.
No, I cannot send any more packet at this point of time. So that's why what I have to do. So a timeout is going to occur. Timeout is going to occur at certain point of time. So this is the timeout, let's say. After the timeout, I have to retransmit the packet with sequence number 0. So by that time, I'm going to send a packet with sequence number 0. RN pointer कहाँ पे है? Receiver में, 3 में. At this
3.
time, receiver के side में RN pointer is pointing to 3. That means it is expecting now a packet with a sequence number of 3. But it is receiving a packet whenever it is retransmitted. It is receiving a packet with sequence number 0. Expecting 3, receiving 0. That's why it is not a valid packet. Not a valid packet. Okay, if it is not a valid packet, it is going to be discarded. Okay, it is going to be discarded, but still it is going to generate an arc on behalf of it. Arc of 1 is going to generate. If it is received successfully, what the sender will know? Now packet 0 is received successfully. So then he goes on retransmit 1, 2 like that. So this is not a problem. That means in this scenario, if I look into, so even if, so I am retransmitting the packet, which is a duplicate packet, should be duplicated, I mean detected as a receiver. So now it is correctly understanding it is not a valid packet. So this packet 0 is not a valid packet. So that means this packet I have already received from previously. So by looking into some other algorithm on. Okay. So now it is expecting a packet sequence number 3. Why? Because 0, 1, 2 is already received. Nah? 0, 1, 2 is already received at his end. Okay. So 0, 1, 2 is already received. There is no need to keep track of it. Okay. So that's why what happens here, it is expecting a packet sequence number 3 at this moment. Any other packets I receive, that is an invalid packet for me. Yummy. How arc of 0? Because my pointer, RN pointer, if I look back into this diagram, RN is expecting a packet sequence number 3. जब तक ये packet sequence number 3 receive नहीं करेगा, it cannot go on. So move its pointer to, move its RN pointer to 0. So that it cannot go and send an arc of 0. And this cannot happen unless until, so my window, so I have already sent 3 packets, nah? I have already sent 3 packets, 0, 1, 2. There is a selective arc. So one is a cumulative arc, one is a selective arc. That means if it says my arc is 4, that is the meaning is 0, 1, 2, 3. The previous, so packets with previous sequence number are already received successfully. Okay. So arc of 4 means 0, 1, 2, 3 had already successfully received at the other end. Okay. So but if it is selective arc and if it says arc of 4, that means it says that only packet 4 is received successfully. It does not tell about anything else if it is a selective arc. But as far as so my go back end protocol is concerned, it is using what? Accumulative. So you have to understand one more scenario with respect to that. I am going to tell you what is the exact problem. Okay, let me go for another scenario here. So here my assumption is that m is equal to 3. If m is equal to 3, my window size can be maximum. So 2 to the power 3 minus 1, that is 7. I can have a maximum window size of 7 if I have a m of 3. Okay. Now in this scenario, so if I look into here, 0, 1, 2, 3, 4, 5, 6, 7, again 0, 1 repeated. Okay. If I look into here, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1 repeated. Okay. So now, so let's say I have 4 packets at this moment. Try to understand a scenario. I have 4 packets to send. Right now, I have 4 packets to send. How I'm going to send these 4 packets, and in case of aeronautic scenario, how I'm going to deal with this? Let's try to understand. Everybody already know. So let me just repeat it so as to explain what is the problem. So let's say first. So first of all, my packet is going to point to 0. That means I can go and send a packet with sequence number 0. Let's say I go and send a packet with sequence number 0. So after sending the packet to the sequence number 0, now what is going to happen? So where is my SF? Where is my SN? Can anybody tell me after sending the packet? So with a sequence number of 0, can anybody tell me? Where is my SF? Where is my SN?
This is 0 to 6.
Yes, correct. So 0 to 6 is my current window. SF is pointing to 0 and SN is pointing to 1. So now, what about RN? At this point of time, RN is pointing to 0. Okay. Initially, RN is pointing to 0. After receiving this packet, can anybody tell me where is RN? Is expecting 0, received it. So RN moves forward and goes and point to 1. After receiving this, okay, but before receiving this, RN is pointing to 0. Okay. So now after this, what happens? So one arc is generated. Arc of 1 is generated. Okay. So now, so then at this point of time, I can go and send a packet with sequence number 1 now, because I have already received a packet with a sequence number. I have already received an arc with a sequence arc number of 1. So now I can go and send a packet with the sequence number 1. So now after sending this, so packet with the sequence number 1, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, dot, dot, dot. Now, can anybody tell me at this point of time, where is my SF, where is my SN, and what about SF will be of 1? What is the meaning of it? 0 packet is received successfully. Are yes or no? If I receive an arc of 1, it is a cumulative arc, if you remember in the last class. So it is a cumulative arc. Arc of 1 means, so packet 0 is received successfully. So that's why, so packet 0 is no more the outstanding packet. It is already sent and acknowledged. So that's why, what is my first outstanding packet? 1, na? Or is it so making sense? So now SF is pointing to 1 because now I send a packet of 1, but till now I have not received an arc of, so for this particular packet 1. So my SF is pointing to 1 and SN will be pointing to 2. And what about my window? What about my window? What is the left wall of the window? Left wall of the window always remain with the SF. And what about the right wall of the window? It will be at 7. Yes? Everybody understood? This is, in this scenario, window slides. After I receive an arc on behalf of the packet I have sent, so my window is sliding by 1 position. So thereby my SF is pointing to 1, SN is pointing to 2, and my window is now started from 1 and ended with 7 because I have a window size of 7. Now, so assume that this packet is lost. Let's say packet 1 is lost. Can I go and send the next packet? Yes or no? So I can go and send a packet with sequence number 2. Before receiving an ARC, I can go and send 7 packets at this point of time. So now I go and send the packet of 2. So that means previously I have already sent 1. Okay. So now what I'm doing, I'm sending 2. After sending 2, can anybody tell me what changes is going to happen here? What changes is going to happen in this window after sending the packet 2? Into 3 and 2 packet is already sent. Okay. SF is pointing to 1. So SN is pointing to 3 after sending this packet 2. Okay. So whenever packet 2 is received, can anybody tell me at the receiver end, is it a valid packet or not? That is the point we have to tell. So RN pointer is 1 means the receiver is expecting a packet with sequence number 1 at this moment. But it is receiving a packet with a sequence number 2. That's why it is invalid. Okay. RN is saying what packet I'm expecting at this moment. So that's why, so till now, it's my RN is pointing to 1 because I have not received a packet with the sequence number of 1 till now. So that's why RN is still pointing to 1. But at this moment, I am going to receive a packet. So that is, so with the sequence number of 2. So it is an invalid packet for me. If it is an invalid packet for me, what the receiver is going to do? Discard this packet. The receiver is going to discard this packet. Even if it is a valid packet, so for the sender, but to the receiver, as per the protocol, go back and it says that, so this is an invalid packet. As it is an invalid packet, it is going to discard it. So whenever it is going to discard it, what it is going to generate? It is going to, even if it is an invalid packet, it is going to discard. Still, I am expecting a packet from the other end with a sequence number of 1. So because I have not received it, so that's why still I have to generate an ARC of 1. Okay. So then, can I send the next packet? Can I send the next packet at this moment? Can I go and send the next packet before receiving this ARC, or even if after receiving this ARC? Forget about after receiving this ARC. Packet 3, now my SF is pointing to 1, so SN is pointing to 4, and now I send a packet with the sequence number 3 because I have 4 packets to send. So 0, 1, 2, 3. Okay, I have already sent 4 packets at this moment. So now I send the packet number, so 3. So that is the 4th packet. Okay. So once it is receiving, again, RN is pointing to 1, it is receiving packet of 3 with sequence number 3. So it is an invalid packet again. If it is an invalid packet again, it is going to discard it. Now it is going to discard the packet. So if it is going to discard the packet, what ARC is going to generate again? It's going to generate an ARC of 1. Okay. So it is going to generate an ARC of 1. That means, so other end is saying, still now I have not received an ARC packet with a sequence number of 1. Okay. So in these circumstances, what is going to happen? So after this, so sending 4 packets, can I send any more packet? Because I don't have any more packet. मेरे पास 4 packet ही भेजने के लिए. Even if the window size is 7, I cannot send any more packet because I don't have any more packet at my end. So that's why what is going to happen? So obviously timeout is going to occur. I have already told, so there is a, so timer. Okay. So timeout is going to happen. It's not for packet 0, sorry. It's timeout is going to happen for packet 1. Because packet 1 is already sent, but I did not receive an ARC on behalf of it. Okay. So as a consequence of it, what is going to happen? The timer is going to times out. Let's say, so timeout occur at this point of time. So after the timeout, what I'm going to do? So can anybody tell me? So what I'm going to do? Do I need to send packet 1 only, retransmit? That means what is saying, why I have to retransmit all these packets? If I look into it, in reality, only packet 1 is lost. But I have to retransmit packet 2 as well as I have to retransmit packet 3 because so the other end has find out these are the invalid packets and he has already discarded. He has not stored these packets at its end. He has not processed this packet at his end. So he treat this packet as an invalid packet, and so it's going to discard all these packets as a consequence of it. So whenever I'm going to retransmit, I have to retransmit packet 1, packet 2, packet 3. Okay. So can anybody tell me? So after retransmitting all these packets, let's look into the last scenario so that you can understand every other scenario as well. So after sending the packet 3, after retransmitting the packet 3, so what is going to happen? So my situation at the sender window is, let's look into that. 7, 0, ... Okay. So now what happens? So whenever a timeout occurs, what the sender is going to do? Sender is going to start retransmitting the packet starting from the first outstanding packet till the SN pointer. Okay, and the first outstanding packet is what? 1, and the SN pointer is 4. So starting from 1 till 3, all the packets are to be retransmitted. So at this point of time, so these are the all outstanding packets, but the first outstanding packet is SF, and my SN points to support. Okay, so after retransmitting all these packets, again my pointers will be, my SF is my first outstanding packet, that is 1, and so I have to retransmit 2 as well, I have to retransmit 3 as well, and my SN pointer is pointing to 4. That means I have to retransmit all these 3 packets at the receiving end. Now let's try to understand, whenever let's say packet 1 is received at the receiver end, what is going to happen? So what about the RN at this point of time? So let's look into that. 4, 5, 6, 7, 0, dot, dot, dot. Okay, so previously RN was at 1. Okay, now what arc is going to generate?
2.
Arc of 2. Yes. Now whenever the packet 2 is received, can anybody tell me where is my RN pointer? Move forward. RN moves forward and move to 3. So as a consequence of it, whenever packet 2 is received, what arc is going to be generated? Arc of 3. Okay, so then, so after receiving this packet 3, so RN is going to move forward again. RN is pointing to 4. As a consequence of it, it is going to generate a arc of 4. And whenever a arc of 2 is received, can anybody tell me what is going to happen to the send window? Send window is going to slide. Whenever I receive, so arc of 3, again SF is going to point to, so 3, and my window is going to slide. Whenever I receive a arc of 4, my SF pointer is going to move, and I receive a, sorry, my window is going to slide. So after receiving this arc of 4, can anybody tell me what is the final situation, if you understood correctly? 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, dot, dot, dot. After receiving this arc of 4, can anybody think of, so where is my SF pointer, where is my SN pointer? SN is pointing to 4. Remember one concept, when SF and SN is pointing to the same, so location, that does mean that you have now no outstanding packet. Okay, even if I say SF is the pointer who is pointing to the first outstanding packet, but whenever SF and SN pointing to the same location, the meaning is that, so there is no outstanding packet. Okay, so now, so I, if at all I can go and send a packet at this point of time, I can send a packet with the sequence number of 4. So that's why SN is pointing to 4, and as I don't have any outstanding packets, because so all the packets has been received successfully. So my SF is also pointing to 4, saying that there is no outstanding packet. What about the window? So left wall of the window starts from 4. So then 7, 1, 2, 3, 4, 5, 6, 7. So right wall of the window will come up here. So this is my current window. After I send all the packets and I receive the acknowledgement, I retransmit all the packets and I receive all the arc on behalf of all the packets I have sent. So this is my current window at the sender, and this is my current window at the receiver. That means at the receiver end, the RN pointer is pointing to 4, where at the sender end, so the SF and SN pointer is pointing to 4, and the right wall of the window is pointing to, so I mean, so completed at 2. This is a complete scenario as far as the send and receive is concerned. So for this go back N protocol with respect to this particular case, packet 2 and 3 is received in the previous scenario, but still as packet 1 is lost, so I have to retransmit all the packets. So that is packet 1, 2, 3 once again. So that is the problem as far as, so what, so this go back in protocol is concerned. So let's look into what is the problem. So problem of go back in. If I look into the problem of go back in, okay, resending multiple valid packets when only one packet is lost. One packet is lost. Due to the loss of only one packet, if I look back into this scenario, so due to the loss of only one packet, even if these are the valid packets, I have to retransmit multiple valid packets to the other end. So that is unnecessarily going to consume my bandwidth. unnecessarily going to take time. So that's why this is one problem as far as the go back N protocol is concerned. And why it is, why this problem is occurring? Because this go back N protocol does not support. Why this protocol, I mean, why this problem is coming? Because go back N protocol does not support out of order packets. Out of order packets. Try to understand what is out of order packets. It does not support out of order packets handling. So that's why, so this problem is, what is out of order packet? See, so whenever I supposed to receive 0, 1, 2, 3, so I did not receive 1, I received 2, so that is a out of order packet. Okay, so there are two things, one is in order, other one is out of order. If I receive all the packets in sequence, so like I receive 0 first, then I receive 1 next, so then I receive 2 next, then I receive 3, all these packet I receive in order, in whatever order. So the sender is sending, if the receiver is receiving exactly in the same order, that is in order, so packet communication. But if in between some packet is lost, like the scenario I have told, so packet 1 is lost, after that I receive packet 2, so that packet 2 and packet 3 becomes out of order packet, because packet 1 is not received and I am receiving packet 2 and packet 3, so before that, so that is called as a out of order packet. So in case of go back N protocol, protocol does not support this out of order packets. Why it is? Because it only points to its only receiver size is 1. Why this is happening? Why I am saying this does not support out of order packet? Because the receiver window size is 1. Receiver window size is 1. So receiver window size is 1 means what it is telling? I can only receive a 1 packet, so that will be a valid packet at this point of time. If I did not receive that packet, any other packet I receive, even if it is a valid packet for the sender, so for me it is an invalid packet. So that's why, so it is going to be retransmitted once again. So that's why these are the two problems. Try to understand very clearly. So resending of multiple valid packets when only 1 packet is lost. And why it is happening? Because go back N protocol does not support this out of order packet handling. And why these out of order packets are not being handled by this go back N protocol? Because the receiver window size at the go back N protocol is 1. So that's why, in order to deal with this problem, the next protocol comes into picture, that is called as a selective repeat. In order to handle this scenario, the next protocol comes into picture, that is called selective repeat. Okay, so